Hi dear students, today we are going to discuss the second part of CBSE chapter motion. In the last class, we have discussed what is motion, rest, distance and displacement. Let us recall that term in the beginning of the class. What is motion? If the position of a body changes with respect to other body, then that body is said to be in motion. Then what is state of rest? If the position of a body does not changes with respect to another body, that body is said to be at the state of rest. Then what is distance? The total path length covered by an object is known as the distance covered by the object. Then what is displacement? Displacement is the straight line distance from initial position to final position. If you specify distance, only the magnitude will be specified. There is no direction is specified for the case of distance. In the case of displacement, both magnitude and direction of the displacement will be specified. Isn't it? Do you understand that? Yes. Then some situations, that means if a body travel in a straight line, that case the magnitude of distance and displacements are equal. If a body moves a certain distance and come back to the initial position, then the magnitude of the displacement that will be equal to 0. These are the content we are discussed in the last video. Today we are going to discuss some more topic regarding with motion. That is, what is uniform motion? Uniform motion. And second is non-uniform motion. Then third is speed. What is speed? Then fourth is velocity. What is velocity? Then last is acceleration. What is acceleration? These are the main topic we are going to discuss in this video. Okay, dear students, first we are going to discuss the first topic, that is uniform motion, and second is non-uniform motion. We are going to compare these two. What is the meaning of uniform motion and non-uniform motion? First we are going to discuss the topic uniform motion. What is uniform motion? Consider an object moving along a straight line. For example, a car moving along a straight line like this. Imagine if a car moving along a straight line. Okay, let it travel 5 meters in the first second. In the first second, this car covers 5 meters and 5 meters more in the next second. Again, this car moves 5 meters in the next second, 2 seconds. Then 5 meters in the third second. The third second, this car covers 5 meters again. And 5 meters in the fourth second. That's why the car covers 5 meters in each second. Okay, that means the car covers 5 meters in each second. In first second, 5 meters. Next second, 5 meters. And third second, 5 meters. Fourth second, 5 meters. That means the car covers 5 meters in each second. That means car covers equal distances in each second. That means if the car travel, if an object covers equal distances in equal interval of time, if an object covers equal distances in equal interval of time, then this object is said to be in uniform motion. What is uniform motion? If an object covers equal distances in equal interval of time, in that case we can say to be that object in uniform motion. That is uniform motion. For example, if a car travels equal distances in equal interval of time, then we can say that this car is in uniform motion. Understood? Do you understand? Yes. If a man running, if the man covers equal distances in equal interval of time, that man is in uniform motion. But in our everyday life, we came across motion where objects over unequal distance and equal interval of time. In some of the situation in our day-to-day life, some objects are moves unequal distance, not equal, unequal distances in equal interval of time. In that case, we can say to be that object in non-uniform motion. What is that non-uniform motion? What is non-uniform motion? Non-uniform motion means if an object covers unequal distances in equal interval of time. For example, if the car travel like this, in first second car travel 2 meter, and the next second car travel 5 meter, and in the third second car travel 8 meter, like that. That means in each second car covers unequal distances. That means if an object covers unequal distances in equal interval of time, that in that case we can say that that object is in non-uniform motion. For example, when a car is moving on a crowded street, that is an example for non-uniform motion. Another case, a person is jogging in a park. A person jogging in a park is another example for uniform motion. These are some instances of some non-uniform motions. Okay, let's watch some of the videos regarding with these two topics, that is uniform motion and non-uniform motion. You can see that a scooter, that scooter is moving in uniform motion, and in some situation you can see that scooter moves in non-uniform motion. In these two cases, you can see the following videos.
In this video, you can observe that scooter moves with a uniform speed. Scooter covers equal distances in equal interval of time. That is uniform motion. That is uniform speed. You can observe the odometer or speedometer. It is noted that 20 km per hour is the speed of scooter. That is, the scooter moves with a uniform motion. That is, scooter in uniform motion. The speed of scooter is same in every time. In each instances, the speed or the distance covered by the scooter is equal in equal interval of time. This video shows non-uniform motion. That is, scooter covers unequal distances in equal interval of time. That scooter moves in non-uniform motion. Scooter covers unequal distances in equal interval of time. That is, scooter is in non-uniform motion. You can observe that in non-uniform motion, the odometer value varies with time, that is, changes with a different speed.
Okay students, what do you understand what is uniform motion and non-uniform motion through that videos? I hope you understood. Okay, next I am going to display one of the table regarding with the uniform motion and a non-uniform motion. This is the table regarding with the uniform motion and non-uniform motion. that is two object A and object B, travel in different situations. That means these two objects starts their journey from 9:30 a.m. and end in 11 o'clock. By observing this table, can you understand which object in uniform motion and which object in non-uniform motion? What is uniform motion? If an object covers equal distances in equal interval of time, the interval of time is equal in this table, that is 9:30, 9:45, 10 o'clock, 10:15, like that. 15 minutes difference, that is equal interval of time. But distance covered, distance traveled by object A in meter is given, and distance traveled by object B in meter is given. In first case, object A first 10 meter, then 20 meter, 30 meter, 40 meter, 50 meter, 60 meter, 70 meter. That means object A covers equal distances in equal interval of time. That means object A in uniform motion. In object B, in the case of object B, first time, that is 12 meter, then 19 meter, 23 meter, 35 meter, 37 meter, 41 meter, 44 meter. That means object B covers unequal distances in equal interval of time. That means object B, we can say that object B in non-uniform motion. Okay, can you understand what is uniform motion and non-uniform motion? Yes. Okay, next topic, that is the rate of motion. The rate of motion. Measuring the rate of motion. What is mean by rate? Rate of motion. What is mean by the rate of motion? Rate means if you are measuring the distance traveled by an each object in unit time, that is known as rate of motion. Look at the situations given in the figures. One is, if the bowling speed is 143 km per hour, what does it means? What do you understand from the signboard of the vehicles? 50 km per hour, 40 km per hour means, what does it means? That is the rate of motion. That is speed of the moving vehicles, moving object. If an object covers some particular distance, then what is the distance covered by this object per unit time? That means unit time means 1 second. What is the distance covered by this object in 1 second, that is unit time? That is known as rate of motion. Okay, that means, let's explain that. Different object may take different time to take a given distance. For example, you and your friend are ready to running 100 meter. That means the given distance is 100 meter. Given distance is 100 meter. Here 100 meter distance want to cover by you and your friend. Okay, and here's you and he's your friend. Then both of you want to cover 100 meter distance. That is the given distances. You can cover 100 meter in 50 seconds. Imagine you can cover 100 meter distance in 50 seconds. Your friend can cover the same given distance 100 meter in 100 seconds. Imagine you can cover 100 meter in 50 seconds and your friend can cover 100 meter in 100 seconds. Then whose rate of motion is more? How can you find out that? That means you can find out how much distance covered by you in unit time. Then we can calculate how much time the friend is taken to cover in unit time. How much distance friend covered in unit time. In that method, you can find out whose rate of motion is greater. Understood? That rate of motion is known as speed of the body. What is that? This rate of motion is known as speed of the body. That means Speed means the distance covered by an object in unit time. The distance covered by an object in unit time, its speed. In this case, your friend and you are covered 100 meter. In this case, your friend and you are covered 100 meter. You covered in 50 seconds and your friend covered in 100 seconds. Then if you find out what is the distance covered both of you in 1 second, that is unit time. Then what is the distance covered? For example, you are covered 100 meter in 50 seconds means you covered how much? 2 meter per second. You covered 2 meter per second. And your friend also 100 meter covered in 100 second means your friend covered 1 meter per second. That means you covered 2 meter in 1 second and your friend covered 1 meter in 1 second. Then whose speed is more? Whose speed is greater? That means your speed is greater than your friend. That means you cover 2 meter in 1 second and your friend cover 1 meter in 1 second. That is speed of the object. This quantity, the distance traveled by an object in unit time, this quantity is known as speed of the object. Then unit of speed is, what is the unit of speed? Unit of speed is, we already given that is meter per second. Meter per second is the unit of speed. Unit of speed is meter per second, or we can write like this also, meter per second. Another unit may be used that in small distances, that is centimeter per second, and in the larger distances we can use another speed, another unit, that is kilometer per hour, or kilometer per hour. Okay, these are the units used for speed. To calculate speed, we can use an equation. What is the equation we want to use to calculate speed? Speed is equal to distance covered by an object in unit time means distance by time. Speed can be calculated using this equation, that is speed is equal to distance covered by unit time, that is speed is equal to distance by time. The unit of distance is meter. Yes, the unit of distance is meter and unit of time is second, that is meter per second is the unit of speed. Meter per second is the SI unit of speed. If you represent speed, the letter V is the letter used to represent speed, then V is the speed, then V is equal to distance can be represented by letter S and time can be represented by letter T. That is the equation of speed is equal to V is equal to S by T. V is equal to S by T is the equation of the speed using letter. In some of the situations, the speed of the object need not be a constant. In most cases, object will be in non-uniform motion. In our day-to-day life, we can see that objects are moving in day-to-day life in non-uniform motion, isn't it? Therefore, we describe the rate of motion in such a way that we describe the rate of motion of one object in terms of their average speed. We can calculate the average speed in the case of non-uniform motion. If an object moves in uniform motion means that object has uniform speed, same speed. If an object moves non-uniform motion means that object have different speed. When object moves in non-uniform speed, then we can calculate the average speed. Then how can we calculate average speed? The average speed of an object is obtained by dividing the total distance covered, the total distance traveled by the total time taken. That is, average speed can be calculated. Average speed is equal to total distance covered by an object divided by total time taken, total time taken to cover that distance. Then average speed is equal to total distance traveled divided by total time taken. That is the equation to find out average speed of an object if an object moves in non-uniform speed or non-uniform motion. Do you understand? Yes. Let us solve a problem. The question is, an object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object? That is the question. Then we know that the equation for average speed, that is, average speed can be calculated that average speed is equal to total distance covered or traveled by an object divided by total time taken. And in this question, the total distance means total distance is equal to 16 meter plus 16 meter. That is 16 meter plus 16 meter, that is means 32 meter. Then total time taken, total time, that is how much? One is 4 seconds. In first case 4 seconds. 16 meter covered in 4 seconds. Again 60 meter covered in 2 seconds. That is total 6 seconds. Total 6 seconds. Then average speed V is equal to S by T, that is S is equal to 32 meter divided by 6 seconds. Then answer is, what is 32 divided by 6? Then 5, 6, 30. Then 2, 0 and point. Then here 3, 18 and 2, that is 5.33 meter per second. That is the average speed of this object. What is the average speed? 5.33 meter per second is the average speed of this object. Understood? Do you understand? The answers, yes. How can we find out speed of a vehicle, speed of an automobile? How can you find out speed of an automobile? That is using odometer or speedometer. By observing the speedometer or odometer, we can find out the speed of an automobile or vehicle. Let's watch another video regarding with the uniform speed and non-uniform speed.
In this video, the motorcycle that moves with a uniform speed. You can observe that the motorcycle moves with a uniform speed. That is uniform motion. Let us notice the odometer or speedometer of the scooter. That is 20 km per hour throughout. In every time the scooter moves with the same speed 20 km per hour. That means scooters moves in uniform speed. In this video, you can observe that scooter is moves with a non-uniform speed. That means in speedometer, the value of speed changes at regular interval of time. At different instances of time, the speed of scooter changes. That is non-uniform speed.
The next topic is speed with direction. What is that? Speed with direction. Speed with direction. We discussed that what is speed? Speed is equal to distance by time. That is distance covered by an object per unit time. That is speed. If you specify the both magnitude and direction of the speed, then this both quantity combined we are using another quantity, that is velocity. That is velocity. Velocity is the speed of an object with a definite direction. What is velocity? Velocity is the speed of an object with a definite direction. That is velocity. Another case, in another term, we can say that velocity is the displacement traveled by an object per unit time. Displacement traveled by an object per unit time. That is, velocity is equal to displacement by time. We know that displacement have both magnitude and direction. In the last class, we have discussed that displacement have both magnitude and direction. Like that, if the displacement is used here, velocity have both magnitude and direction. Velocity have both magnitude and direction. Well, what is velocity? Velocity is the speed of an object with a definite direction. With a definite direction, we know that displacement have a definite direction. If you use a displacement, we get velocity instead of speed. In this, instead of this distance, we are replacing displacement. We get velocity. If you are replacing distance using displacement, we get velocity. That means the unit of velocity is the same. That is, the unit of displacement is meter, and the time, that is meter per second. The unit of speed and velocity is same. That is meter per second. Like speed, velocity may become uniform and non-uniform. When the velocity becomes non-uniform, if the value of speed changes in a straight line cases, if an object moves in a straight line, then if the value of speed changes, that means the velocity also changed. Then if the direction of the motion changes, then velocity also changes. That may be it is uniform velocity, not non-uniform velocity. It may be non-uniform velocity. If the object or both, if the direction or magnitude of speed will be changes, that means that velocity is non-uniform velocity. If a body moves in a straight line with a uniform speed, that in that case that a body moves in uniform velocity. If the body moves in different speed in straight line, then that body in non-uniform velocity. And if a body moves in different direction, then that body in non-uniform velocity. If the magnitude of speed and both direction and magnitude of speed changes, that is also non-uniform velocity. In the case of velocity changes at uniform rate, if velocity changes at a uniform rate, the average velocity can be find out the arithmetic mean of initial velocity and final velocity at a given time of interval. How can we find out the average velocity? Like speed here, average velocity can be find out. Average velocity can be find out that. How can we find out the means? If an object moves, if the velocity of an object changes uniform rate, if the velocity of an object changes at uniform rate, then average velocity can be find out the arithmetic mean of initial and final velocity. That is, average velocity is equal to initial velocity plus final velocity divided by 2. Arithmetic mean, initial velocity plus final velocity divided by 2. The arithmetic mean of initial velocity and final velocity, that can be written like this: average velocity is equal to initial velocity plus final velocity divided by 2. If we denote velocity using letter V, V average, VAV is equal to initial velocity can be represented by letter U and final velocity can be represented by letter V. Then U plus V divided by 2 is the equation to find out average velocity when object moves with a velocity which is changes at a uniform rate. In that case, we can find out average velocity. VAV is equal to U plus V by 2, where U is the initial velocity and V is the final velocity. Next, we are going to another problem, that is, Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to other and back along the same straight path. Find the average speed and average velocity of Usha. That is the question. Usha swim 180 meter for a long pool, 180 meter in 1 minute, and come back to same path and come back the same path with the same speed, 1 minute. Then what is the average speed? Then average speed can be find out. Average speed can be find out, that is total distance divided by total time taken. Total time taken. Here total distance is 180 plus 180. That is 180 plus 180 is the total distance covered. That is divided by total time. 1 minute, that is 60 seconds. Divided, and here 60 seconds, that is 60 seconds plus 60 seconds. That means here is 0 and 360 divided by here 120, and 0 cancel, and here 3 meter per second is the average speed of Usha. The next we are going to find out, that is what is average velocity. Then average velocity can be find out, that average velocity, that is displacement by time, displacement divided by total time taken. That is displacement. What is the displacement of Usha? She start from initial point here and final point also same. That means initial and final points are coincide each other. That means displacement is equal to 0 divided by 60 plus 60, that is 120. Here 0 by 120 equal to 0. That means the average speed of Usha is 3 meter per second and average velocity of Usha is 0 meter per second. Next topic is rate of change of velocity. Rate of change of velocity. Change of velocity. In the case of uniform motion or in the case of uniform velocity, we know that when an object moves with uniform velocity in a straight line means the value of velocity does not change with the time. That means change of velocity, there is no change of velocity. That means the rate of change of velocity will become 0 in that case. When an object moves in uniform motion, moves in uniform velocity, in that case there is no change of velocity. That means the rate of change of velocity that becomes 0. For example, if a car moves with the uniform velocity, the uniform velocity value is 5 meter per second through a straight line. Okay, if this car moves along a straight line with a uniform velocity value 5 meter per second, then there is no change for velocity for this car. That means the rate of change of velocity that will become 0 for this car when the car moves in uniform motion in a straight line. Okay, in non-uniform motion, velocity varies with the time. In non-uniform motion or non-uniform velocity, velocity varies with the time. It has different value in different instances. Velocity has different values at different types of instances. For example, a car is moving with different velocity with a different time. For example, sometimes it may become 5 meter per second, and sometimes accelerator applied, then become 10 meter per second. The velocity become 10 meter per second. And sometimes it may become 2 meter per second. Sometimes it may become 20 meter per second. Like that, the velocity vary with the time. That is non-uniform motion. That is non-uniform velocity. and it has different value of different instances at different points of path. Thus, the rate of velocity of object during any time interval is not zero. In this case, the rate of change of velocity is not equal to zero in this case. Then can we now express the change in velocity of an object? Here, changing velocity of rate of change of velocity, we are use another term that is known as acceleration. That is known as acceleration. What is acceleration? Acceleration is the rate of change of velocity. That means the change of velocity taking place per unit time. The change of how much change of velocity takes place in unit time, that is known as acceleration, or rate of change of velocity is known as acceleration. We know that in our vehicles there is an accelerator. For what purpose that accelerator is used? Because if you are applying accelerator, then the velocity changes. If you increase the accelerator, then acceleration increases means velocity increases. The change of velocity increases in different instances. The velocity increases means that motion is known as accelerated motion. If you apply brake means velocity decreases. In that time, it is known as retarded motion or retardation. That is known as retardation. The velocity decreasing motion, the rate of velocity decreasing is known as retardation. The rate of velocity increasing is known as accelerated motion or acceleration. The change of velocity per unit time is acceleration. If the velocity increases per unit time, that means velocity, that is accelerated motion. If the velocity if the velocity decreases per time, that means that is retarded motion or retardation. In the case of accelerated motion, that means if the velocity increases time to time means the value of acceleration become taken as positive. If the velocity increases time to time means the value of acceleration become positive. If the value of velocity decreases time to time means the value of acceleration become taken as negative. Next we are going to discuss that how can we find out acceleration. That means, for example, if an object moves with a velocity, initial velocity u, if an object moves with the initial velocity u and after some time, after some interval of time, the velocity changes to v at the time interval t. If an object moves with the velocity u, after the time interval t, the velocity changes to v. Then we can say that acceleration can be represented letter a. Then acceleration a is equal to change in velocity divided by time. What is acceleration? Acceleration is the change of velocity per unit time. That can be represented as acceleration a is equal to change in velocity by time. Then what is change in velocity? Here changing velocity means initial velocity changes to final velocity v. U changes to v in the time interval t. Then a can be represented, a is equal to final velocity minus initial velocity, that is change of velocity, change in velocity. What is change in velocity? Change in velocity means final velocity minus initial velocity divided by time. That can be represented using letters a is equal to change in velocity means final velocity minus initial velocity. Then final velocity is v minus initial velocity u minus v minus u. Time is t. Then a is equal to v minus u by t. That is the equation to find out acceleration of a body. Acceleration of a body. If an object moves with a velocity u, after some time the velocity changes to v in the time interval t, then we can find out the acceleration of the object. A is equal to v minus u by t. Then what is the unit of acceleration? Here change of velocity means meter per second is the unit of velocity, divided by time means here is also second. Meter per second means meter per second square. Meter per second square is the unit of acceleration. it can be represented like this, meter per second square. That is the unit of acceleration. There is another term used for acceleration, that is uniform acceleration. Uniform acceleration. What is uniform acceleration means? If the velocity increasing or decreasing at uniform rate. If an object travel in a straight line and its velocity increases or decreases by equal amount in equal interval of time, that means velocity increases or decreases at a particular rate, that acceleration of an object is known as uniform acceleration. For example, if you are dropping a stone from a height, the motion of a free falling body, here stone is a stone in free falling because there is no disturbance when this stone is falls, that means free fall. The motion of a free falling body is an example for uniformly accelerated motion, that is uniform acceleration. What is the example for uniform accelerated motion? Motion of a free falling body is an example for uniform acceleration. Then what is non-uniform acceleration? What is non-uniform acceleration means, if the value of velocity increases unequal amounts in equal interval of time, in that case we can say that that is non-uniform acceleration. Uniformly accelerated motion. For example, if a car traveling along a straight line road increases speed by unequal amount in equal interval of time, then the car is said to be moving with non-uniform acceleration. If the velocity increases in uniform rate, or if the velocity increases or decreases by equal amount in equal interval of time, that is uniform accelerated motion. And if the object moves with unequal velocity in equal interval of time, that is non-uniform accelerated motion. Okay, do you understand my topics? Then today we are discuss that what is uniform motion and what is non-uniform motion, what is speed, what is velocity, what is acceleration, and uniform acceleration, non-uniform acceleration. Okay, last we are going to discuss one of the question based on the acceleration. Then I am going to wind up this video. Thank you for watching my video.
Starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meters per second in 30 seconds. Then he applies brakes such that the velocity of bicycle comes to down 4 meters per second in the next 5 seconds. Calculate the acceleration of the bicycle in both the cases. In the first case, initial velocity u is equal to 0, final velocity v is equal to 6 meters per second, time t is equal to 30 seconds. From the equation of acceleration a is equal to v minus u by t, we get the value 0.2 meter per second square is the answer. In the second case, initial velocity u is equal to 6 meter per second, final velocity v is equal to 4 meter per second, time t is equal to 5 seconds. Then acceleration a is equal to minus 0.4 meter per second square.